Hey, all you pre-calc peeps. This is Mr. Ainsworth here, and we are going to go through application of lesson 2.9, where we're talking about the binomial theorem, or how to raise a binomial to a power. So, yesterday during our lesson here, we went through quite a few examples here. We went through x plus y, and we squared it, then we cubed it, excuse me. We took it to the fourth power, and then over here, we took our three results here and we wrote them next to one another, and then I extracted, which took out the coefficients here, and then I wrote them off to the right, and we took a look at patterns here, and this thing that we call Pascal's triangle comes out. You guys saw this last year, but this year what we want to do is get good at it and use it to expand a binomial to a power. Okay, and then yesterday, let me see, we did this example here. We took x plus y to the seventh power. And then I think, if I remember correctly, we took it to the eighth power, and we did a few more examples on the whiteboards. And you guys were awesome. So tell the person next to you, you're awesome. All right. And so now what we need to do is get more practice, because guess what? We just touched the tip of the iceberg. So everybody slide it to the side and record and take notes through here, because I'm going to go through some application of what we talked about. Okay, application of Pascal's triangle and how to expand a binomial to a power. All right, so here we go. Strap your seatbelts on, okay, and roll up your sleeves, because Ainsworth's going to get started. Okay, so here we go. My first example here, we're going to take the binomial 4x plus 1, and we're going to take it to a third power. We start simple with positive numbers and not a very high power. Okay? Now, the first thing that you guys have to remember is that when you expand a binomial to a power, you want to look at the degree here, which is 3, and you want to add 1 to it, and that will tell you that you need the fourth row of Pascal's triangle. So we need to go 3 plus 1, and that will give you the fourth row of Pascal's triangle. That's the first mental thing you do when you expand it. Okay, and what we're going to do is use those coefficients, okay, which are at the very top of the screen here. It's 1, 3, 3, 1. So when you cube a binomial, take it to the third power, we're going to be using the coefficients on the fourth row. So you have to be good at it. Okay, and if you don't have Pascal's triangle in front of you, you have to generate on your own. So you have to go 1, and then 1, 1, and then 1, 2, 1. Okay, you add the two middle numbers there, and then 1, and then 1 plus 2 is 3, 2 plus 1 is 3, and then you end it with a 1. And that's called row 4, R4, which means row 4 Pascal's triangle. And these are the coefficients of your binomial expansion. That's how you say it. The coefficients of your binomial expansion. Okay, tell that to the person next to you right now. Go. All right, now let's apply it. So here we go. The first term is 4x and the second term is 1. And you need to know what happens with your exponents. So actually, let me review with you right here. So take a look at part B here. The coefficients of x, which is your first term. This is just your first term here. And y is your second term here. The coefficients of x decrease by 1, and at the same time, the coefficients of your second term increase by 1. And you have to remember that. Okay, so here we go. All right. So this is going to be equal to our first term, 4x, raise it to the third power. Notice you can put a 1 there in front if you want. That's our first leading coefficient. And notice that I put parentheses around the 4x. And if you don't do that, you're going to get the wrong result, guys. So pay attention. Parentheses, when you raise a monomial to a power, parentheses are important. Okay, plus, you put the coefficient in now, 3. So again, let me put these in red. So the first coefficient is 1, the next one's 3. And then what you do is you take it and you multiply it by 4x to the second power, because it reduces down a degree. All right, times the second term times 1, okay, times 1, plus the coefficient here, which is 3 again, times the first term, which is 4x, and it goes third degree, second degree, first degree now, and then times 1 to the second degree. So now the coefficients of the second term are getting bigger here. So, and then again, and then plus 1, I guess. You can put the coefficient in there, I guess, if you want. Times the last term raised to the third power. So times 1 raised to the third power. So notice in red, I put the coefficients of your triangle in, okay? And then you simplify. So here we go. So 4 cubed. Well, 4 cubed, I'm just doing a little side work here, is 4 times 4 times 4, and that's 16 times 4, and that's 64. Okay, so here we go. You get 64. Come on, Ainsworth. 64 times x cubed. You got to square or cube the variable as well. So 64x cubed plus, see, 3 times whatever 4x squared is, and that's times 16x squared times 1. All right, we'll simplify that in a moment. And then we've got 3 times 4x, which is 12x times 1, and then plus 1. So last step, let's simplify. We got 64x cubed plus 3 times 16, 48 times x squared. The 1 has no effect. All right, plus 12x plus 1. And there you go. And that's how you expand that binomial there using the coefficients of Pascal's triangle. So again, you go to the fourth row, and then you use those coefficients in your polynomial expansion. Remember, the degrees of your first term decrease and your degrees of the second term increase. So what do I mean? We'll take a look at this in blue. So it goes third degree, second degree, first degree, and then 0 degree. And then on the second term, it goes 0 degree first, and then first degree. So 0 degree, first degree, second degree, third degree. So the second term increase in powers by 1, and the first term decrease in powers by 1. And if you understand those patterns, then doing something like this is pretty straightforward. Okay, we're going to be working on a few of them here, so I'm just giving you guys what's called experience. So now let me throw in a negative here to show you how to handle that one now. Okay, so here we get 2x minus 1. We're going to take that binomial, and let me see. Let's take it to the fourth power. Let's change it up. All right, let's get crazy in here, right guys? Let's get crazy. So I'm going to take that to the fourth power and see what happens. Okay, so let's raise it to the fourth power and let's get started. So now pretend we don't have the triangle in front of you. The first thing you do is you have to understand that we're going to raise it to the fourth. So I want row 5. I need row 5 of Pascal's triangle. So that's your first mental step, okay? And then you generate it. So you generate it, and the reason why you generate it every time is so you get good at it. So 1, 2, 1 is your third row. 1, 3, 3, 1 is your fourth row. 1, 4, 6, 4, 1 is your fifth row. And so here, there's your fifth row, and that's what we need. That's row 5. R5 is row 5. Okay. So here we go. So I'm going to take my first term now. And you can, again, if you want to put a 1 in front and to start us off, you can, although that has no effect. So you just take your first term to the fourth power. So 2x to the fourth, okay, plus, and now we're using the coefficients of Pascal's triangle here, so which I'll put in red. I'm going to put 4 there. All right, times your 2x to the third power. Remember, they go down. The coefficient or the exponents of the first term decrease by 1. The coefficients of your next term increase by 1. And the next term is minus 1, and I got to take that to the first power. All right, plus, and I'll simplify later, okay? I'm just going to expand it right now. Plus 6 times your first term, 2x to the second power, times your negative 1, which is your second term, to the second power. Again, the second term increases power, the first term decreases power. And then plus 4. Okay, then times the first term, 2x to the first power, times the next one, the second term to the third power. And then I have to do the, oops, sorry. We'll do the last one here. Just trying to create some room here for you guys. All right, so plus what? Plus 1 times the second term. Ooh, 2v fourth power. Okay, just creating a little bit more room right there. So now, once you expand it, now you simplify it. So here we go. We got 2 to the fourth. And again, 2 to the fourth is equal to 2 times 2 times 2 times 2, which is 16. So I get 16 x to the fourth here. And again, you raise 2 to the fourth and x to the fourth. A very common mistake is that people forget either one. So they think of it as 2x to the fourth, which is wrong. So 2x to the fourth, you got to square both the 2 and the x. So keep that in mind. Plus 4 times 2x cubed. Now 2 cubed is 8, so times 8x cubed, and then times a negative 1, which I'll simplify later. And then I've got plus 6 here. So 6 times 2x squared, which would be 4x squared, times 1, because guess what? Negative 1 squared is 1. Plus 4 times 2x, well, I'm going to simplify that to 8x. And then times negative 1, because negative 1 cubed is negative 1, and this 4 times 2x is negative x. And I'll multiply those together when I fully simplify it here in a minute. And then negative 1 to the 4th is just 1. So notice that I'm simplifying a little bit at a time, especially since I'm teaching right now. Okay, when I do this on my own, I do a lot of mental math. So, and you guys are going to do that too. When you're really good at mental arithmetic, you're going to skip all these steps and you're just going to write the answer. And so what is the final result? We get 16x to the fourth. 4 times 8 is 32 times negative 1 is negative 32 x cubed. 6 times 4 is 24, so 24x squared. I'm going to change from plus to minus because 8 times negative 1 is negative 8, so minus 8x here, and then a plus 1. And notice that the signs are alternating, okay? Alternating signs, and that always happens when the second term is negative, okay? Alternating signs. That happens up here because you have 2x minus 1 to the fourth power as opposed to 2x plus 1. So whenever you have a difference in the binomial, when you're subtracting, the signs are going to alternate. Okay, and there's your next example there. So now let's get you guys involved, okay? Now we're going to pause and play through the video because we've already done 2, and now it is your turn. So let me come up with one. Okay, so let's think of a good one, Ainsworth. So next example, 3x minus 1. No, wait a minute. Let me see. That's different. It's got to be different than the last one. Okay, that is. All right, to the, we're going to go big time here. No, we don't want to go too high in power. Let's just go to the fourth power. Okay. Now, again, we're not looking at past triangles from before, so don't scroll up and get your coefficients, which I know you can do. Generate it on the side. So the first thing you do is you generate the triangle first. Okay, generate the fifth row. So the fifth row, sorry, the fifth row first, okay? So pause the video, generate the fifth row, and let's see if you're right. And then when you're ready, press play, okay? And let's interact here. Okay, let's interact. Go. Okay, so I'm going to assume that you generated. So here we go. Let's check. 1, and then 1, 1, and then 1, 2, 1. 1, 3, 3, 1, 1, 4, 6, 4, 1, and there's your fifth row. Okay, that's row 5. So 1, 2, 3, 4, 5. There's your fifth row, and these are the coefficients you need. All right, now we go for it. Okay, so now here we go. So now what we want to do is let's get you guys involved some more. So go ahead and do the first step of the expansion, kind of like I did on the first example here, using the coefficients, and then press play when you're ready, and we can check step by step. All right, go. All right, so I'm going to assume that you've done your first step. So here we go. So we're going to have 1 times 3x to the fourth. all right, plus your coefficient 4 times 3x to the third times negative 1 plus 6 times your first term to the second power times your second term to the second power plus 4 times your first term, which is 3x to the first power times negative 1 to the third power plus negative 1 to the fourth power. Okay, so there's your first step in the expansion right there. And notice that the coefficients are 1, 4, 6, 4, 1. I didn't, if you want to put the ones in, you can. Okay, all right, step 2, simplify what you see. Okay, go. All right, so now what do we have? Okay, so 3 to the fourth, 3 times 3 times 3 times 3, that's 9 times 9, that's 81. Okay, so here we get 81 times x to the fourth plus 4 times 3 cubed. 3 cubed is 3 times 3 times 3, which is 9 times 3, or 27. So times 27x cubed times negative 1. I'll simplify in the next step what that is here in a minute. All right, plus 6 times 9x squared times 1. Again, I'm just simplifying step by step. That's all I'm doing. All right, and this is how you get to your results, okay? 4 times 3x is 12x. So 12x here times negative 1. When you cube a negative 1, you get negative 1. But if you take negative 1 to the fourth power, you just get 1. All right, and now the final step, okay? Simplify it. Go. Okay, let's check the end result, my friends. Okay, we get 81 times x to the fourth plus, okay, when you multiply 4 times 27, that's 108. But times negative 1, that's going to change the sign, so I'm going to switch to a minus sign. All right, so 108 minus 108x cubed. All right, plus 54x squared minus 12x plus 1. All right, give the person next to you a high five if you got it. Go. Okay. All right, and there it is. All right, so what we're going to do now is just, let me see, we've done 3 examples. We're going to just do one more, and then you guys can do your homework. Okay, so let me see if we can, let's see, let's take it to a higher power. Okay, let's challenge you guys a little bit. So let me change what I was going to do. Oh, this is really going to stretch you. Okay, here we go. All right, here we go. Are you guys ready? All right, tell me to bring it on. All right, shout it out. Tell me to bring it on. All right, so I'm assuming that you guys told me to bring it on. Let's take 2x minus y and raise it to the 6th power. Okay, now tell the person next to you what row on Pascal's triangle we need. What row? All right, if you said 7th row, you're learning something, okay? So 6 plus 1 is 7, so we need 7th row, okay, of Pascal's triangle. So we need to generate it, all right, without looking at our notes. So we generate first, okay? Pause the video now. Go. Generate 7th row. Okay, here we go. 7th row. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And let's count the rows, okay? Row 1, row 2, row 3, row 4, row 5, ooh, row 6. Guess what? We need to go one more. 1, 6, 15, 20, 15, 6, 1. And there's row 7. Okay, row 7. Now we're going big time with this example. Okay, so these are the coefficients we need. Here we go. Holy cow. This is a doozy. Okay, now the first step of the expansion. All right, so pause the video and just do the first step only. Okay, go. Okay, So now we're going to take 2x minus y to the 6th. Okay, my first term is 2x. So I have 2x to the 6th power plus 2x to the, oh, excuse me, sorry, back it up. Ooh, I forgot to pause the video here. Oh, no, we're checking. Okay, so let me check. Sorry, 2x to the 6. All right, plus your coefficients here. And here we go. We need a coefficient. So I'm going to put in 6. So that's my first coefficient. All right, times 2x to the 5th times negative y to the 1st. All right, plus my next number here, which is 15. So this is going to be a doozy, guys, okay? Times 2x to the 4th times negative y squared, plus my next coefficient, which is 20. So times, and again, the powers of the first term go down. So I go 6th degree, 5th degree, 4th degree, 3rd degree. And my next one here, my next term, negative y, that's going to be increasing in power. So 1st degree, 2nd degree, 3rd degree, plus my coefficient. Now I'm on the 15. So I'm on my 5th term right here. So 15 times 2x to the 2nd power times negative y to the 4th power. All right, plus, and I've got 2 more coefficients to go. 6 times 2x to the 1st power times negative y to the 5th power. And then my last one, I'm going to take negative y to the 6th power. And there we go. Holy cow. So look at those coefficients, okay? So you'll see them in the expansion. 1, 6, 15, 20, 15, 6, and then 1. So you generate the triangle first, and then you go crazy and you simplify. Okay, pause the video here. Let's see if you guys can simplify that without a calculator. Okay, go. All right. Let's check to see if you're right. Okay. Now, 2 to the 6th. If you know your powers, powers of 2, they go like this: 2, 4, 8, 16, 32, and then 64. Okay, the 64, that's 2 to the 6th power. Okay, so 64. So I've got 64 here times x to the 6th. Next one, and I'm only going to simplify part of this at a time just to make you guys understand, because this is a video, right? So, and I'm not there, so it's kind of hard to ask questions. So here we got 6 here times 2x to the 5th power, so that's 32 times x to the 5th, all right, times negative y. And we'll simplify the negatives here in a little bit. And then we got 15 times 2x to the 4th, which is 16x to the 4th. Now, negative y squared is just y squared. When you square negative, it's positive. Okay. And then what else? Okay, so we got 20 now. So 20 times 2x to the 3rd power, that's 8x cubed. Now, when you take negative y to the 3rd power, that's just negative y cubed. Plus 15 times 2x to the 2nd power, that's 4x squared. And then when you take negative y to the 4th power, that's just y to the 4th because they have an even power. And then we have that 6 right there. So 6 times 2x, well, that's just 12x. So let me just write it as 12x. Okay, and then your negative y to the 5th, well, that's just negative y to the 5th because it's an odd power. And then plus y to the 6th, and that's an even power. So you just get a positive y to the 6th there. Because when you take a negative to an even power, the negatives cancel. Okay? All right, now we got to simplify everything. So if you guys are ready, keep the video playing. If you're not, press pause. Okay? And then go for it. And let's see what we get. Okay, final step. Holy cow, we got 64x to the 6th plus 6 times 32, that's 180 and 12, 192, times x to the 5th, times a negative y, which is going to make the sign change. So I'm going to change it from a plus to a minus and then multiply it by y. So we have a sign change there because Positive times a negative is a negative. Okay, that's it. Okay, and then we have 15 times 16. Now 15 times 15 would be 225 plus another 15. That's 240. Okay, so if you can't do that in your head, you go multiply 15 times 16 and you get 240. So you got 240 there times x to the fourth times y squared. 20 times 8 is 160 times negative 1 is negative 160. So change signs right there. Times x cubed times y cubed. 15 times 4 is 60, so we get 60x squared times y to the fourth. 12 times negative 1 is a minus 12 times x times y to the fifth plus y to the sixth. Holy cow. If you guys can do that, you are awesome. Okay, and you know what you're doing. Okay, so one thing is important here when you're learning new techniques. First of all, this is a video, right? And so what you can do is you can replay it and check it out and practice. Second of all, if you had to take notes a lot and you couldn't do this on your own, then what you do is you adopt the principle of perfect practice, okay? And perfect practice, okay, let's write this down. Perfect practice makes perfect. Okay, there was a common saying many years ago that practice makes perfect, and I totally disagree with that. Okay, you have to practice in the right way, and which means you got to do the right thing, develop the right skills, because you can practice bad habits and you get worse. But if you practice good habits, you get better. So you got to check your work for quality. Okay, so look at the person next to you and say, always check your work for quality. All right. And there's 4 examples for you. So now what you guys need to do is go into section 2.9 homework here, 2.9 homework. Do that with each other because now you should be able to do it. All right, and I'll see you back in class. This is Ainsworth signing off. Take care, guys.